Alright, ladies and gentlemen, in this video we're going to go ahead and do another example of a proof. In the first question, part of the question, it says redraw triangles ABC and DCB side by side with the corresponding parts in the same position. Now, you can do this a couple different ways, but I think it's just going to kind of help us just visualize which ones match up. So let's go ahead and just do a couple of redraws here. So I'm going to go ahead and just basically move the triangle DCB. Let's go ahead and move this guy down right here. Oh, that was terrible. Move this guy down. Go in that same order, DCB. So let's think about this. There's my right angle. There's my hypotenuse. So when I redraw triangle ABC, I want to make sure that all of them match up. Well, C is our right angle and B is our right angle, so they're going to have to match up. And then go in order, and again, you can always kind of tell of what order you want to go in, because if we go from D here and B at the top vertex, and then kind of notice the order that I have in this triangle says D is first and B is second, we'll go to this triangle, they'll match up. A is first down here, and C is up here, and there will be our side-by-side comparison for this example. Now I'm going to go ahead and erase these drawings, but you can kind of see the purpose, and it really helps us identify which particular pieces will match up with one another. Okay, so let's go ahead and look at our proof for this example. So what do I know? Well, it says use the information given to prove the following triangles are congruent. Well, first and foremost, I'm given that BD is congruent to AC. So there we know that BD is congruent to AC. CA, if I'm going in BD. Okay, and I'm just going to put a little h over here, little h, that's going to be our hypotenuse. And that is given information. I am given that angle, and I'm going to be specific here, ABC, and angle DCB are right, back up a little bit here, are right angles. That is also given to me. So what else can I dial in? Well, that allows me to now state that I have two right triangles. So I can say that triangle ABC and triangle DCB are right triangles. And what told me that? Well, that's because the definition of right triangles. Definition of right triangles tells me that once I have two angles, or an angle in each respectively, then I have right triangles. This is good because I have to prove this if I'm going to use hypotenuse leg theorem. So I want to go ahead and use my hypotenuse and then figure out what leg can be proven congruent. Well, again, what do you notice? Shared sides. Man, I'm hoping we're understanding that common theme. I see that BC is congruent to CB. Again, the order matters because they would be in opposite orders in those two triangles by our reflexive property of congruence. And so let's go backtrack. I have the hypotenuse congruent. Here is my leg. I'll put a little L to the left of it for leg. Hypotenuse, leg, right triangle, theorem. Two triangles are congruent. Triangle ABC is congruent to triangle DCB by the hypotenuse leg theorem.